Okay, so we are starting with our basically our orthographic projections of our cube. And so this is our 4-inch cube that we made in AutoCAD on a 1/4-inch grid. And if you notice, I've got the plan. Go to top here. I've got the plan drawing here. I've got a front elevation. I've got a roof plan, and then two side elevations and a section. And I didn't actually import the section from AutoCAD, like the section line. So I'm just going to go ahead using Snap. So I'm going to go ahead and draw where that section line comes from. If you don't have the section lines, you should put those in there just so that you can line these up properly. What we're going to do is we're going to build what we call a scaffold model. And in order to do that, right now these are all separated on different lines and on different layers. We want to make these into groups. So select each drawing and then just type in group. And we're going to repeat that for all of the different pieces of the scaffold. Now when I click on each one, it's one thing. And that's kind of what I want. I want each one to be one thing. Okay? And I'm going to go ahead and go to perspective view. And I'm going to move these into position. And then I'm going to rotate them. So take us first front elevations. They move. Move it, snapping to the back corner here. And then once I have it, I'm going to rotate it into position. And we call this like the Amish barn raising. We're going to do a rotate 3D. We're going to draw the axis that we used to rotate it. That's the hinge. And then you're going to want to draw like basically the angle that it starts with, the 0-degree angle, and then holding down the shift key, which will force the orthographic snap, you can basically raise it up immediately into position. So that is now the front elevation. Okay, and we do the same thing with these other pieces, although we're going to need to rotate them. So we'll go rotate, standard rotate, and the center of rotation is going to be here. And I'm going to hold down shift again, and holding shift rotated into the proper orientation. I'm going to do the same thing here, although even though it's the same as the other side. Then we're going to go ahead and move and rotate 3D these pieces as well. It's a good idea to do these kind of in sequence and to repeat similar commands. That way you're not like duplicating effort. One of the benefits of the computer, right, is like repetition. Is it's very easy to make copies of things. It's very easy to repeat commands. So it's simpler than continually changing commands to run a series of commands that are more similar to each other. So we do the two moves, and then we'll do the two rotate 3Ds. So the rotation axis in this case is on this side. Be very careful to have snaps, and only the snaps you need when you do this. You don't want to be imprecise here because it's going to cause things not to line up. Snapping here, snapping up, and then to do the same thing on this side, this angle to that angle, and you can see that starting to like line up with each other. If you start to see the column, starting to see this volume here, and then the last piece of this puzzle without the section is going to be this roof plan. Now here I'm actually going to snap in 3D because I'm going to pick this corner. And if I actually choose this corner here that's in 3D, you notice that it actually moves up and it moves in the X and the Y. That's one of the nice things about 3D, is that you can get snaps in 3 dimensions, but it can be bad because it can cause you to snap to things you don't want to, so you have to be really careful about how you do that. Okay, and then the last piece is going to be a section. And you can see here, I hope you understand that the section is really critical here, as I mentioned in lecture. Like, it reveals actually a lot about what's going on in this project, because otherwise you wouldn't actually be able to read what's going on with this roof aperture, and also how this plinth actually reads all the way through the back of the space. Okay, you wouldn't know that. You wouldn't know how that works without this. So I'm going to go ahead and rotate this as before, and it's kind of gone out of axis, but that's okay because I'm going to go ahead and move it to the section line that I drew. And this is getting kind of confusing, so what can I do? Well, I can hide these, right? Showed that. And then I could rotate 3D using the section line as my hinge, and then just following that same procedure to rotate that up. And then when I'm ready, I can go ahead and show those other sides. And that's my scaffold. Now at this point, it'd be a very good idea to save your file, right? Because you've already gone ahead and you've created your scaffold. Make sure always to save your file frequently. Make backups of different iterations of your file so that you don't lose any work. Particularly as you model, because modeling in Rhino can be destructive. And as I've shown you, what that means is that if you're performing operations on objects, sometimes that'll actually erase the objects. And so it's hard for you to repeat that command to make another object if you've lost those pieces. So saving copies of your files can help you recover those pieces should you forget that. Let's go ahead and make a layer. We can just call this solids or something, which is basically going to contain our pieces. I'm going to go ahead and move that up to the top layer next to the default. And I'm going to say set current. So now whenever I make I make objects, they're going to be black and they're going to be on the solids layer. So let's go ahead. And, there really isn't any, you have to kind of plan ahead in terms of the way that you understand your scaffold model. In this case, I had this big volume here, and so I'm going to kind of start with that. And I can do this in lots of different ways. I could do a rectangle, and then I could extrude it. Actually, I'll go ahead and show you that method. So I typically don't extrude directly from the lines that I generated. Because in many cases they didn't come in very well from CAD. I might have done a lot of trims and things, and so they're not joined lines, they're maybe multiple overlapping lines. So to maintain precision, particularly in a simple model like this, I use the scaffold literally as a frame, and on my layer I'm going to go ahead and draw the line I want, which is actually this roof line. And you can kind of see that here. Okay. And then I'm going to go ahead and start by extruding it, extrude curve, down and snapping here. So I get this chunk that I have. Okay. The other way I could do it, if I know what I'm doing, is I can make a box. So I could start at this corner, and I'm going to go ahead and snap to. So I'm snapping in 3D to the bottom corner of this because I don't have a corner. I guess I do here, but I shouldn't have a corner that I can snap to. This is, again, and if I model this correctly, if I drew this correctly in CAD, I shouldn't have a line there, but I do. I can grab this in the Z, and then I can use that same line to create the Z coordinate for that. So I'm already starting to kind of model that kind of base thing. And then the other piece that I want to do, see these little L-shaped pieces in the plan here? I'm going to trace these. I could make this out of a couple of boxes, but I don't want to do that because I want it to be an L-shaped extrusion. I want these to be as clean as possible when I make these. So I'm going to go ahead and do that. I'm going to go ahead and extrude that and snap it to here. And you can see I'm already starting to see that in front view. You can work on multiple views if you're not comfortable with working in the like perspective view as I showed you. This is really handy too. You can say zoom extents or zoom extents all if I right click, and that'll actually zoom all these to the same orientation. What I can do, so I've got this piece here and I know it's the same as the other piece, so I can go ahead and mirror that using my section line. I'm very careful, and you can also change views while you're in the viewport, so that's kind of nice. So I can use this top view to orient that piece for me while I'm in perspective. So it's pretty nice. Okay, so I've got that volume kind of built here. I'm actually going to go ahead and I'm going to hide a bunch of this stuff because it's in my way. The next piece that I want to make is actually this. Go ahead. Yeah, I'll just look at this. Is this piece here? This red plinth. So I'm going to go ahead and I'm going to draw this polyline. And I can do this because I'm drawing basically on top of the plan. I'm not snapping to anything in 3D, so I'm not worried about my lines being out of plane. You can't extrude anything that's not planar, as in it's not in the same plane. So that's really important to know. So now I've kind of redrawn this plinth here. To turn show back on, and I'm going to go ahead and extrude it again, or extrude it to be the height of that plinth. Okay, now you can see I finished that plinth there. Okay, And I'm going to go ahead and finish off the rest of the stairs in a similar way. So I'm going to go ahead and hide what I can. I'll go ahead and hide this too. I don't want to accidentally snap to that. It's really key for me. Hide these two. And once I've used that curve, I can actually delete it. I don't really need that anymore, and it might kind of get in the way. So I'm going to go ahead and delete that piece. Okay, so the other two pieces I'm going to draw. I'm going to draw a rectangle for this set of stairs, and a rectangle for this set of stairs. And then I'll turn these back on. I'll use those lines. I'll extrude those lines. So the first one, extrude curve. Notice how I've got the same thing drawn in multiple drawings. I could snap to here, I could snap to there. It doesn't really matter. Okay, and if I go to wireframe, so I can pick this line. Notice these different view modes, like the wireframe makes it easier to select lines, but the shaded view makes it easier to kind of find the snaps I want from the solid. So you're always changing your perspective, you're always changing your view mode to be optimal. So now if I do that, I've got these things nested in each other, it's really clean. Okay, not too bad. Okay, then the last two pieces, one of these is that I've got this column. But the column really, I mean, I could take it here and extrude it all the way up, but that might not be very clean. So I'm going to go ahead and I'm going to draw the curve for the circle, and then I'm going to move it from where it is up to the top of the plinth. And I've accidentally moved it. So I'm going to go ahead. That's why it's useful to have the project snaps. Project is going to keep it in line there. There we go. So now it's actually lined up. And then once I do that, I can extrude that to the proper height. So I'm not making any geometry that I don't need. It's not embedded in anything unnecessarily. The project snaps, like what I just did there, was it basically restricts what I'm doing to a two-dimensional plane instead of snapping to things out of plane. And I needed that so that when I moved this in the XY along the plinth, it wasn't going to jump to anything else. So that's kind of a brief explanation of why that works. Okay, so I've kind of got that stuff working. The last piece of the puzzle is going to be this this cavity here, this like aperture. Okay, and the way that I could model this in two different ways, basically. But I'm gonna go ahead and show you both ways. Okay, so the first thing I'm gonna do is basically just model this as a positive and then Boolean it out of this geometry. Before I do that, I need to make these two things a solid, or it's not gonna really work too well. So just join these two together, and I'm gonna say Boolean union, and that should be, now they're treated as one object. Okay, then I'm gonna go ahead and I'm going to once again draw, and see I've got project snaps on, so that doesn't work. See, that's one thing where project snaps is not gonna like work too well for me. Oops. Hang on. Let's try a different kind of circle. Let's do a diameter circle, and that way I can actually use this red circle. You can see on the object there that I'm actually talking to this piece and not to something down there. So that way I've got that object redrawn. Okay, so I've got that circle. And then what I want to do is essentially I want to draw a circle here. And that's going to be a little bit more challenging for us. Let's actually go ahead and I could do the same thing. So I could basically draw using my section, draw that circle in diameter, and then I could probably do like a rotate 3D operation. Let's just go ahead and hide all this stuff, make it easier to figure out. Don't want to hide my section. Okay, so I've got my section. Turn off the roof too. And these. None of that. Okay, so I got my section. I'm going to go ahead and rotate this in 3D. So it starts up, and I want to go flat with it. And voila. Okay. And it actually does this kind of funneling thing here. So what I want to do in this case is just copy this to here. So now I've got the outlines of this, and then I can do a loft. 1, 2, 3, and do a straight loft, straight sections, and that's going to create a funnel for me. And actually, I'm going to go ahead and just cap. Go ahead and cap this. Okay, then I show everything, and then if I do a Boolean difference, and I subtract this thing, it's going to give me a funnel. It's easier to see and shaded, so you can really see that. I can see all the way down there. And that's actually going to give me my project. And if I go ahead and hide those guide layers now, that's it. So I just created that from my drawing. Not a great model. I will certainly tell you. I'm just doing this for just as an example. Okay. But that works good enough for us for now. Let's go take a step back and talk about something, sort of review Booleans here. So I did this Boolean, but I actually don't need to do that Boolean the way that I did it. I did that whole process there, and I could actually use, I could actually trim. Hang on a second here. If I explode this, and I don't have a top to it, so I don't have a top on it, and I don't have a bottom on it. Just go ahead and hide all this stuff. But just get rid of these. So all I have is the, let's go to ghosted here. I have the surface on the inside, and then this box. I can actually use the curve to trim the box, and then if I join everything together, it's the same as if I did a Boolean. I'll try to explain this a little bit. So if I go trim, go back to shaded here. Trimming object is going to be either the curve or it could be the surface itself. I could do the surface, it's fine. And I click inside that box. It's going to trim that away. Same thing on the bottom here. So I go trim. The cutting object is my surface. And the object to trim, and I have to click inside of that or it's not going to work. And so what I've done is, oops, just trim the whole thing. Okay, enter when I'm done, and if I go into my properties here, now I have an open poly surface, and I have an open surface. Well, since they're pretty much, made up of all the parts are like trimmed equally, this would be the inside and this would be the outside. If I join those together, now I have an open poly surface. Let's try cap again and see if I can't get that to heal. Yeah, now it's closed. There must be some little, oh shoot, that didn't work too well. Oh, I see, I need to do both pieces of it. There's actually more, there's more pieces. Okay, I have to be careful of that. Let's do join. Now it's closed. Okay, I cut the top box and I cut the bottom box, but I didn't join all the pieces together. Okay, so now that's a closed poly surface. So I've essentially accomplished what a Boolean does, but I didn't subtract it. I'm sort of like a tailor making a shirt or a pair of pants here. I have a piece of fabric, like a surface, and another piece of fabric, and if I sew them together and they're perfect, the computer treats them as a solid. So again, precision modeling will save the day where a Boolean won't work. And I'm saying this because Booleans don't always work, and you gotta be really careful with that stuff. Okay. So we go ahead and we go back to layers, and we're gonna go ahead and hide everything. Now, for the last part, in order to get your model of your formwork, when we start thinking about what that looks like, is going to be to get the negative space of this. And as I said in class, it's pretty easy to do. If you can Boolean everything together as a union, and that should work assuming your model is well built and everything lines up and they're all solids, everything should Boolean together pretty well. And in fact, this is considered a closed poly surface, which is just fine. Then you can go ahead, and if you're really careful, you can create the formwork. And I'm going to do this, let's see here. So if I did, yeah, we'll do a center box. That's 5 inches by 5 inches. Okay, and we'll use this to be our box. So we're going to extrude it, and we're going to extrude it 5 inches. Let's look at it in wireframe here. Okay, front. Okay, then we're going to move it. And little tip, if you want to move something without knowing the exact coordinates of it, you can move it a relative distance. So I'm going to say move it 0 R for relative, negative 0.25, that's a 1/4 inch. Oops, I gotta do this again. Okay, move from point to move to, actually R0, negative 0.25. I did that wrong. Yeah, there you go. So I moved in the Y 0.25. Actually, I need to do that same thing again. I didn't, I should have moved it 0.5. Okay, one more time. R0, R.5. Ah. Negative 0.25. There we go. Okay, now it's should be centered in the box on all sides. That's good. So it's like going to be contained by that mold. Okay, and then the other piece of it I'm just going to go ahead and trim. Go ahead and trim this box. And so what I end up with is this, and I'll just go ahead and cap it. So now I got a solid, and of course, since I want 2 halves of it, I'm going to mirror it. Alright, 2 boxes. And why do I do this? Well, because if you just put the object in a box and you Booleaned it, it wouldn't look like anything. It's probably just going to look like the object inside of a box. It's not going to really give you a good sense of that like formwork. You can verify this experimentally. Go ahead and try to Boolean it out of a 5-inch cube. It's not going to look like much. If you Boolean it out of a 4-inch cube, however, that might be interesting. Let's actually go ahead and do that. Let's make a copy of this. Again, making a copy because it's a destructive model. If I do this, it's liable to, well, it will destroy my model. So I'm just going to go ahead and make a box. Okay, so I've got these two pieces here. We'll go ahead and save a copy of this too. Quick way to do it is just your incremental save. Okay, so one thing I can do, let's just do this Boolean difference. I'm going to subtract from the box this guy. And so this is actually going to give you just the like negative form. Okay. This is actually probably just right for the assignment, but it's not the formwork. I think you get that. This is the negative of it, but it's not actually the formwork. Okay, and you'll notice too, there's actually pieces of it that I can't really see, but when you look at it later, you'll be looking at it in kind of a wireframe view. It's actually technical, probably. You'll be able to see that when you look at it through the hidden line drawings. Okay, so to look at the formwork, what I'm going to do, we do the same thing. I'm going to make another copy of this whole contraption here. So we'll do one side of this thing, and then we'll do the other. So you do Boolean difference, subtract from the cube this thing. And now you can see it actually gives you, something that looks like formwork. And whether it would work or not, well, it probably won't work, but we can talk about that a little bit more later. But at least it gives you an idea of the kind of cavities and things you have. Same thing here. Subtract. And just get rid of these curves and things. Or just make sure that all you've got left is the solid. And if you're smarty pants, you'd say, well, make it symmetrical. This is the same thing as that. Well, yeah, that's true, but some of yours aren't, so I wanted to show you that method. There are different ways of cutting this box up in order to sort of give you some more interesting views of your artifact. Okay? And we'll sort of talk about that later. But that's basically how to get the negative of your positive form, both as just the negative space or as something that exists as part of a mold. Okay. All right. That's it for this part of the tutorial. I'll see you guys in the next part where I talk about how to get these into two-dimensional drawings.